Hi Jonah, here's your video. So we're going to look at tonight cubics, factorizing and the remainder, or I'm just going to give a very brief reminder on that one because we because we've done it before. So I know that you can do it. So I'm just going to give you a question to do and you can get back to me on the answer. Then we're going to look at the binomial expansion that you asked me for, and I told you, or hinted, that you already know how to do it. That's another advantage of the technique that I use to multiply out brackets and factorize quadratics, cubics, quartics, and so on. Because guess what? It's the same technique to do the binomial expansion. Initially, anyway. So we're going to get the same thing. So let's have a look at the cubic first. So I'll just set you a question to do there. I've already set it up for you, which is 8x cubed plus 6x squared minus 14x plus 3. And you want to figure out what is going to be you're going to get when you times it by 4x minus 1, or what you'll get when you divide that cubic by 4x minus 1. So the first thing is to determine whether it's a factor or not. So how would you do that? If it's a factor, what would be the solution that you'd put in? So think about the answer for a moment, and hopefully you got a quarter. 4x minus 1 equals 0. So x must be a quarter. 4 quarters minus 1 is 0. Put a quarter in and see if it gives 0 itself. So you need to do a quarter cubed times 8 plus 6 times a quarter squared minus 14 quarters plus 3. And if you do that, has it come out as a factor or not? So pause the video and figure it out. Okay, having done that, you should have found that it is a factor. It does go in perfectly. If it wasn't a factor, doesn't matter. Let's say it came out with 1 as a remainder. What would you do then? Well, what we can do is just take the remainder off, so it would become same cubic but plus 2 on the end. And then you would just divide, or multiply, not divide, but figure out what the quadratic will be for 4x minus 1. And then you'll get your answer, and then you'll just have your remainder on the end of it, divided by 4x minus 1. Okay, so that's the trick to get around it. If it's not a factor, it doesn't matter, just make it a factorizable by taking that remainder off. Okay, so this one is a factor, so I want you to yourself just tell me what the quadratic is by email when you get this video and have a go at it, okay? So pause the video now and just have a go yourself. Okay, so going on to the binomial. Where a binomial expansion comes from is, funnily enough, multiplication of brackets. So I've got this one set up. So again, I just want you to have a go at this. So pause the video again and multiply these out, and what will it give? So hopefully you stop to do that, and then here we go. So we're going to get, whoops, wrong thing. We're going to get 1, 2x because of the cross, and then x squared down the left hand column. If we then multiply that by x plus 1, do the same thing. Now this time I'm going to use the 3-digit method like we did for the cubics. So this is exactly the same thing. We're going to multiply the right hand column, so that's going to give us 1. Then we're going to do the cross, so that's going to give us 2x plus 1x is 3x. Then we're going to do the union jack, so that's 2x squared plus 1x squared is 3x squared. And then we're going to do the cross, which is x cubed. So we get x cubed plus 3x squared plus 3x plus 1. We multiply that by x plus 1. Now this is done with the 4-digit technique, which I taught you yesterday. So it's exactly the same, except the fourth step is that double cross shape. So first step is going to be 1. Second step is going to be 3x plus x, which is 4x. Third step is going to be 3x squared plus 3x squared, so that's 6x squared. Fourth step now is a double cross, so we're going to do x cubed times by 1 plus nothing, 3x squared times by x, and 3x times nothing, so that adds up to 4x cubed. And then finally, well in this case finally, we're going to do the union jack, and that's only going to give us x cubed times x, because it's the left hand side now, yeah? It's going to be the left hand side of the three terms on the left. So x cubed, 3x squared, 3x, and x is what's in that union jack. So we just got 1 that's going to multiply, because the others here will give zeros. So it's x cubed times by x, and that's plus x cubed, x to the 4, which is just outside the picture that I've set this up for. So let me just move that so you can see it. There we go. There you can see it going. So x to the 4. And that'll be the fourth line. Now if you look at these numbers, hopefully you can see a pattern emerging. You mentioned a triangle in your email. So you look at the coefficients, the numbers times by x. At the start we've got 1 and 1, and then it goes 1, 2, 1, and then it goes 1, 3, 3, 1, and then 1, 4, 6, 4, 1. Do any of these ring a bell at all? So hopefully that will look like that what's called Pascal's triangle. Pascal was one of the people to discover this. It was probably discovered by other people, but he managed to get his name on it. It generated this sequence of numbers. Now this sequence of numbers, I think, is the most important sequence of mathematics. And in particular, at 1, 2, 1, the coefficient or number 1, 2, 1 is the most, I think, most important number in maths. But you've probably never heard of it before as being important, apart from if I've mentioned it. And that's because it's the initial what's called a binomial square. So we have a quick look at that. Here we go. So let me move my page again. So this is what a binomial square looks like. In other words, it's just a square shape because it's a square. But it's when two things are multiplied together. So we did x plus 1 times x plus 1. And that gave us an x squared, 2 x's and a 1. And this is just a more general version of it. So on the right hand side, the red and the blue, forget the beads and all that stuff, the orange things, beige things. Look at the red and the blue. So the red represents the x times by the x, so it's x squared. The blue represents the 1 times the 1, because if you think that the a is x and b is 1, it's x plus 1. There's also, I don't know why, but they put gaps in it. This wasn't written by a mathematician, so it's not perfect. But I just thought I'd use it as a reference. So x plus 1 times by x plus 1. So we've got x squared. This area here is going to be 1 times by x, so it's equal to x. This one is 1 times by x, so it's equal to x. And this is 1 times 1. So we get x squared, 2 x's, and 1. So there we go, x, 2, 1, 2, 1. That's called a binomial square. Now you might be heard of it at school as a perfect square. Right, there's no such thing as a perfect square, unfortunately. It's one of those things that they say at school. A perfect square implies the existence of an imperfect square, which there's no such thing unless you think of it as a rectangle. But I just call it a rectangle then. So something's either a square or a rectangle. I don't know why they call it a perfect square, but a binomial square is what they should call it, because it's made up of two parts. A and B, x and 1, 10 and 1, whatever. So going back to the whiteboard, if you quickly calculate 11 squared, what does it give? Hopefully you got 1, 2, 1, 1, 2, 1. And if you calculate, let's get that back in the shop, if you calculate 11 cubed, what does that give? Hopefully you got 1, 3, 3, 1. Same coefficients, like 1, 3, 3, 1. And you can see where this is going, 11 to the power 4. What coefficients, without any calculation, what do you think that's equal to? And of course it's 1, 4, 6, 4, 1. So there's a pattern there. And the underlying pattern is that arithmetic is algebra, algebra is arithmetic. And that's why it all works so well. So if we want to multiply two numbers together, and we do algebra in the same way, like we are here on the left, we get the same answers, because it's all the same thing. Okay, so you might be thinking, alright, that's kind of give me a sense of what's going on here. But what do all these letters mean? So this x squared plus 2x plus 1 is that binomial square shape we saw. It's basically just the area of a square. If x is 10, for example, the area would be 121. Here, this cube is called a binomial cube. Very important shape as well. And there's a very special school called, I don't know if you've ever heard of it, you might have heard the name before, Montessori school. Italian woman who was way ahead of her time. and she gives children what's called a binomial cube to play with, and it's a 3D representation of this algebra. Now, when I googled binomial cube, all I ever saw really was this, and that's because you'll only ever see it in terms of letters in the mainstream stuff. But if you want to see what it looks like in reality, it looks like this. So I'll just scroll up. Binomial cube. So this is the toy that is, I say toy, it's more like a math learning device. And it's given to between 3 and 6-year-olds in the school. So just 3 and 6-year-olds are given this A-level maths to do, except they never tell them that, they just get on with it. And there's the binomial cube itself, if you can see that. So a plus b cubed is a cubed plus 3a squared b plus 3 plus 1. So notice the coefficients are 1, 3, 3, 1. So what you get is a cube of side A, so in that case for us that would be x. This one would be x squared times 1 for us, so when we get 3 of those, that's why there's a 3 in front, so 3x squared. 3ab squared would be the 3x that we got earlier, so that means that this has got an area, this blue bit's got an area of 1, it's 1 squared, times by the height, which will be x. There's 3 of those, 3 x's altogether. And then finally, the 1 cube, the b cubed. It's very clever stuff, and I've got a binomial cube at home, so I'll bring it with you, with me next time I see you. Okay. If you look on YouTube, there's a few videos about how to make one. You can get a better idea of what it looks like from that. There you go, it's only a minute long.
This is called the binomial cube.
So this is
start by taking the pieces out.
A maths teacher, yeah, it's just some primary school teacher who doesn't really know what's going on mathematically, which
Black
is the amazing
on
thing.
black. Black on black.
So
now there's
they
a
do
little
it by
blue
colour and memory
area.
and stuff like that. But there we go. So it's a
Put
cube.
that in. You'll know that you've done it properly.
It's a cube. Lost my train of thought now. Yeah. So it's a cube made up of 2 parts, hence the x and the 1, or 10 and the 1, or whatever. And for the binomial square, we get the area of the square, and for the binomial cube, we'll get the volume. So these just represent the different volumes of each part. And when you add them all up, they form a cube, which then can fit into a box. And what the teacher was trying to do was give a intuitive understanding to little children of algebra. It's quite incredible. So I was very impressed by that. Anyway, so that's how we can calculate the binomial expansion for anything. But the trouble with this multiplication is, although it's for us not too bad because we've got a quick method, there is a faster way, and we can use the pattern that we know that we're always going to get these coefficients out when we do this multiplication. And it's due to the fact that multiplication is addition. So we know that it's 1, 2, 1, and 1, 2, 3, and 3, and it's just down to the pattern that we use of the column, cross, union jack, double cross, and so on, that these numbers come out. So if we change this to x plus 2 and multiply by x plus 2, it's still going to really contain the 1, 2, 1 as a kind of fundamental answer, but it'll be a multiple of it. So x plus 2 in numeric terms will be 12 if x was 10. So 12 squared is 144. And what happens is we get a 2 times 2, which is a 4, and then we get 2 plus 2, which is 4 there. So it's still the same thing underneath it. For a cube, same thing again. If it was x plus 2 cubed, then it would be this would be x plus 2 again. So it would be x plus 2 times by x squared plus 4x plus 4. The 144, of course. And that would then give 8 here, and so on. Okay. So the x plus 1 is like the fundamental, and then anything after that is just a combination of them. Now the faster way of doing it, I'm not sure, I think the Pascal triangle way isn't very good really, because okay, the pattern's underneath it, but I wouldn't use that to figure out a binomial expansion. So what you need to know about is something called combinations. So I'm going to leave it there for now, just as a kind of, I hope that's given you a bit of background. And next time I see you, I will give you a quick and easy way to do the binomial expansion, used for anything. So let's say you wanted to do, I don't know, something like 2x plus 3 to the power 5, something like that. What you need is a fast way of doing it, which doesn't rely on writing out a triangle. So I'll show you how to do that. If I don't see you, if you need to know that beforehand, let me know, and we'll try and figure something out next week so that we can at least meet up, even though your house is undergoing constructive surgery. Yeah, so let me know what you think about that anyway, and then we can go from there, can't we? If you've got any questions on it or whatever. Alright? So, first thing is, remember that fat cubic. Let me know how you got on with that, what the answer is, and also tell me what you think about this, and if you need to know more. Alright? I'll speak to you soon.